Uh, we're looking at the implicit differentiation, okay? Differentiation of implicit function, okay? If you look at all our previous differentiations in previous video, it has been a differentiation of just one variable, okay? But here, you'll be having two or more of different variables, okay? So look at here now, s squared plus y squared equal to 1, okay? So this one is s squared. So the variables are what? Are not the same. So that's what we call the implicit differentiation, when you are differentiating respect to different functions. Okay? So let's see how we can go about that. This one, step one, differentiates respect to what? With respect to x. Differentiate with respect to x. So this will be equal to dx of this plus dx of this equal to what? Equal to 0. Differential coefficient of 1 is 0. So you can see now that this one, the s squared, is differentiated respect to what? Respect to x. But here, y squared, okay, is a function of itself, is a function of y, is a function of y, okay, and at the same time, and also a function of what? A function of x, functions of x. So let's see how we can do that. So this will give us 2x. This one, what we'll now do is this. It's very simple. That will be plus d dy. It's a function of y, okay? D dy of y squared. Okay, then next thing, let's differentiate respect to what? Respect to x. Okay? So, and equal to what? Equal to 0. So that's how to do that. Y squared is a function of y. So that means respect to y. Okay, and at the same time, it's a function of what? Of x. Differentiate respect to what? Respect to x. Differentiate the y respect to x. Okay? So that's that on that. And that will give me and if you don't want to do it this way, you can just, okay, write or 2x plus derivative of, you can just straight away differentiate that, that's 2y, differentiate that 2y, and then put the y dx beside that. Okay? You imagine it's a function of y, you differentiate straight away, that's 2y, the y dx equal to 0. But I think this one is more better. Okay, so this will give me 2x y squared respect to y, that's at 2y. Okay, dy dx equal to 0. Then you can make this one the subject by looking for the y dx. Move this one to the other side, and that's what? Minus 2x. So the y dx is what? Minus 2x over 2y. So 2 we cancel. We have minus x over y. So we have this question. Find the y dx if s squared plus y squared plus sine y equal to 3. Okay, let's go straight. So this is s squared plus y squared plus sine y equal to 3. So differentiate respect to x, and that will give us 2x. Okay, and this one will give us what? Plus d dy of what? Of y squared, and then dy dx. Don't forget what we said at the beginning, that y squared is a functions of y, okay, and also functions of what? Functions of x. Okay, so you do it with respect to y, okay, and then the y dx. So, and this will be equal to what? The same thing also, d dx of what? of d dy of sine y, and then followed by what? dy dx equal to 0. Okay? And if you don't want to be doing it this way, you don't want to waste your time, just imagine it's a function of y itself. So just write 2y and then put the y dx by the side. This one also cos y. You put the y dx by the side. Okay? So this one will be equal to 2x plus this will be 2y dy dx, then plus the differential coefficient of sine x, that's cos y dy dx equal to 0. Then you can factorize your dy dx now, and that will be equal to, move this on to the other side. So we have 2y plus cos y into bracket dy dx equal to minus 2x. So dy dx is equal to what? Minus 2x over 2y plus cos y. Okay. So that's that on that. And as I was saying, if you don't want to be wasting much time, if you like this one now, this question, you know that this is respect to x, we are differentiating respect to x, so this is automatic 2x. This one is not function of, it's not direct, it's not functions of x. So you just differentiate this one, okay, straight away, respect to y, that will be plus 2y. Then you put the y dx by the side. Okay, this one also straight away, cos y. Then you put what? The y dx by the side. Okay, so that's that in the first differential and second differential for this expression. Okay, and I've explained in the previous example that this one is a case where you are differentiating with respect to different functions. Okay, so first thing you do is to differentiate respect to what? Respect to with respect to x, with differentiate with respect to x. Okay, so which will be equal to 1. This one will be equal to what? d what? d dx of y, then dy dx, because y is a function of itself, it's a function of y, and at the same time, but differentiate with respect to what? Respect to x. So that will be d what? d dy of y, and then times the y dx. Okay, y is a function of y, so that's what we're doing respect to y, and at the same time it's also a function of x. We are differentiating with respect to x, so that will be what? The y dx. So plus d what? d dx sine what? Sine y dy d dx. So this will be d dy, and then equal to the differential coefficient of 3 is 0, d dy of that. So that will be equal to 1 plus, when you differentiate y respect to y, that was 1, so we have the y dx, plus here that will be cos y, cos y dy dx equal to 0. Call this one equation start, because we're going to make reference to that when we want to do the second differential. We'll make reference to that. So can we make the y the subject? So that will be equal to 1 plus here 1 plus cos y dy dx equal to 0. Move this one here to the other side. So we have 1 plus, we have dy dx equal to minus 1 all over 1 plus cos y. So we've gotten our dy dx. Equation star differentiates equation star with respect to x again, so that we can get the second differential. So that will be equal to, if you differentiate this one, 1, that will be 0. Okay, and then plus d what? dd respect to x, d dx respect to x of what? of the y dx. Okay? Here is a product rule. So you take one constant, differentiate the other one. Okay? So if I'm taking constant now, cos y, I'm taking the constant. That means I'm now differentiating d what? D dx of what? Of the y dx. Okay, then the next thing for me to do now is to take my dy dx constant and differentiate cos y, okay, which is equal to what? Minus sine y dy dx, okay, equal to 0. Okay, so that will now give us this one will give us the square y dx squared, then plus cos y. This one will also give us the square y dx squared, and then minus sine y dy dx twice equal to 0. Okay. Then we can factorize these two. And that will be equal to 1 plus cos y into brackets the square y dx squared equal to, move this one to the other side, which is equal to what? Minus sine y. And don't forget, we already gotten the y dx, okay, before, okay, which is this one. And that's what? Minus 1 over 1 plus cos y. Okay, so, and that will give us, we can now have now the square y dx squared equal to, multiply this one, that will be sine y all over 1 plus cos y. We are dividing by this, okay, and that will give me 1 plus cos y, that will be all square. So that's the second, your dy dx is what? Is this value, and don't forget the square, okay. So by the time you square, this minus become positive, so you have minus sine, okay, and then power 2, and then you are dividing by this one, you are dividing by this, so times 1 over 1 plus cos y. Okay, by the time you are divided by this, it will change to multiplication, and then 1 over this. So your final answer is what? Minus sine y all over 1 plus cos y power 3. Okay, so this one is positive. You move it to the other side, so this becomes positive. Okay, now become positive. So this is positive. Okay, so that's that on this. The main thing is that this kind of work, when you are doing second differential, you must be focused on that and don't allow distractions so I will not miss small things there. Okay, so that's that, and we're going to play with more questions. So let's take one more questions. Okay, before we take one more question, I want to say something here. When you are here, the first differential, the y dx is equal to minus 1 over 1 plus what? 1 plus cos y. You can get your second differential from here, okay, instead of differentiating equation start. Okay, if you want to do this one again, that will be equal to d dx of dy dx. Okay, and if you differentiate this one now with respect to x, you can see that this one is a function of y. So it's going to be d dy of that function, okay, and then times the y dx. Okay, so when what you are doing is not it doesn't have that function with respect to x. This is y. You first of all differentiate with respect to y, and then finally you put your what? The y dx by the side. Okay, so this is what we have here, which means we can use this one, get the quotient rule, use quotient rule to differentiate this one with respect to y, which will be equal to what? 1. Don't forget, I want to use the quotient rule. My u is minus 1, then the u, the x is 0, and the u, the function of y, the u, the y is 0. My v is 1 plus cos y, then the v, the y is minus sine y. So let's use the formula, which is v du dx minus u dv dx. all over v squared. So which is equal to v is what? Our v is 1 plus what? 1 plus cos y times u dx is 0. So minus into brackets u minus 1 times the v dx. The v dx is what? Minus sine y all over b squared 1 plus cos y squared. So here this one will cancel. You have minus, so that's minus what? Minus sine y over 1 plus cos y, and then times your dy dx, which we have here. That's what? Minus 1 over 1 plus cos y. So if you do that, that will give you minus sine y over this one. This one is what? Power 2 here. And that's what? 1 plus cos y power 2. So that's that on that aspect. Okay. Please, this topic still continue. Want to see the part 2 so that we can have opportunity to play with as many questions as possible. Okay. So please, if you are new on the channel, please hit that notification bell so that as we upload, you get notified. Thank you for doing that, and join the next video.